Is our universe just one of many in an infinite, ever-expanding multiverse? What exactly is the multiverse? Is it just a speculation of us humans, or could it be that our universe is part of a multiverse? In this article, we will discuss these questions. We have used the theory of multiple universes in cosmology, physics, philosophy, astronomy, religion, science fiction, comic books, and fantasy. We will only focus on the evidences and facts and observations made by astronomers, and then draw a conclusion on the topic. The three-dimensional world which we witness in our daily lives may just be an illusion where there is no distinction between past, present, and future. But how is it possible? How can we be so wrong about something so familiar? These questions bother almost all astronomers and physicists. It's a groundbreaking possibility that opens up a whole different world for us. We will discuss an important question. What if alternative universes are being formed all the time? The Big Bang might not be a unique event. We might live in a duplicate parallel reality among the many other parallel realities. Somewhere there's a duplicate of you, me, and everyone else. Are we in a universe or a multiverse? Uniqueness is an idea so unusual that no one questions it. A recent picture of the cosmos is coming to light, where nothing is unique. This recent picture challenges the notion of uniqueness, in which duplicates of things are unavoidable. There might be duplicates, not only of objects, but of me, you, and everyone else. And if it's right, where are they? Why haven't we seen them? There was a time when the word universe meant everything that existed. The notion of more than one universe seemed impossible. But if we go beyond our Milky Way and even beyond the distant galaxies and beyond the end of the observable universe, we might find that our universe is not alone. There might be other universes. In fact, there might be new universes being born all the time, might have stars, and even a planet that looks familiar. We may be living in an expanding sea of multiverse. Some of these might not have the basic requirements for the formation of matter. Others might have planets, stars, and galaxies that look familiar to us, but with a slight difference. And if there are many other universes out there, some might be even identical to ours except for the slightest details. For example, in any other parallel reality, it might be possible that I am the Prime Minister of India. And if the multiverse exists, we will have to encounter a lot of possibilities that might exist. There could be other places where duplicates of me would exist and would think, act, and speak in the same way as I do, but with some slight differences. Is it science? Is it religion? Is it philosophy? As a physicist, we should not, and we don't ask these questions. We follow the logic, and the logic leads there. There was a time when people thought Earth was at the center of the cosmos, and everything else that exists revolves around us. Then scientists like Galileo and Copernicus showed us it's the sun that's at the center of our solar system. And our solar system is just a little neighborhood in our gigantic galaxy. And our galaxy is among the billions of galaxies that make up our universe. These ideas sounded shocking and outrageous when they were first suggested. But now we don't even think to question these ideas. The idea of different alternate universes or the multiverse might be the same. It just requires a radical change in our perspective of the cosmos. So let's talk about, where did the idea of multiverse come from? What are the evidences of its existence? Well, a lot of astonishing discoveries and theories have suggested we may be a part of the multiverse. The very first among them is the Big Bang, the theory of the origin of our universe. According to this theory, our universe began 13.8 billion years ago in a very hot and dense, violent explosion of a very tiny primordial nugget. Over millions and millions of years, the universe cooled down and it led to the formation of stars, galaxies, and planets. The universe is still expanding because of that explosion. But there's one major piece of this theory that's missing. The Big Bang tells nothing about what caused the explosion, throwing everything outwards. What caused the bang? So what furled the violent explosion? What force could set everything moving outwards? In 1979, a young physicist, Alan Guth, laid the foundation of the idea of the multiverse. He and his mate Henry Ty wanted to know how the particles might have been formed during the early universe. Alan discovered something exceptional about their equation, about how new particles were formed in the early universe. In the math of his equations, he found out the evidence in the harsh environment of the early universe the gravity can be repulsive and act in reverse. This repulsive gravity would drive apart everything around it and repel it, causing a massive expansion. This force was so powerful that it could take a molecule and blow it up to the size of a galaxy in less than a billionth of a blink of an eye. This spectacular realization gave birth to the theory of inflation. This powerful gravity caused the bang in the Big Bang. This repulsive gravity caused the universe to expand outwards. Two Russian physicists, Andrei Lind and Alex Velikin, found out that the equations of inflation had an appalling secret. Our universe may not be alone. Alex Velikin had attended one of Alan Guth's talk on inflation. He was so fascinated about the idea that he slept on it for months. He thought, what exactly happens when the inflation ends? The more he wondered about inflation, the more he wondered about what would make it stop. He then realized after months that the end of inflation doesn't happen everywhere at once. And if it doesn't happen everywhere at once, there might be a place where it might still be happening. In this theory, the Big Bang was not a unique event. There were many Big Bangs that happened before ours, and many more might occur after that. New Big Bangs always occur, and an alternative universe is always being formed, yielding an eternally expanding universe. They incited the idea that inflation is a never-ending phenomenon. We know this idea as the eternal inflation. Velikin explained the idea to others, but the problem was that his ideas could not be observed, because not only the universes were expanding, but also the space between them, and nothing would reach us. And other scientists would lose faith in listening to his theory when they were told by him we cannot observe it. Eventually, with no sound evidence to support his theory, he lost hope and shut down his work on the idea. On the other hand, his friend Andrei stuck to the idea, and it would take Velikin 10 years when he would return to his idea because of the unexpected support it gained from observations and studies later. The theory of multiverse gained unanticipated from the two areas of science. One was the string theory, and the other was a breathtaking discovery made by scientists observing universes on a large scale. A discovery that's baffling if there's only one universe. But if we are a part of a multiverse, it's suitable to think of it. It's related to the expansion rate of our universe. Let's take an example. Let's take a baseball. When the ball is thrown upwards in the air, after some time its velocity becomes zero and it comes back to Earth because of the gravitational pull of the Earth. Astronomers knew that the universe was expanding and thought it would slow down in the same way because of the gravitational pull of the stars and galaxies. But when the observations were made by the astronomers, they found out that the universe is not slowing down. It's expanding at an increasing rate. This new discovery baffled them. It's just like throwing the ball up in the air, and instead of slowing down and coming back to the Earth, it keeps speeding up and moving away from us, eventually into space and away. If we observe something like this with the ball, we would assume there's an invisible force behind it. Astronomers called it dark energy, discovered by mainly three scientists, Adam Rees, Saul Perlmutter, and Australian astronomer Brian Schmidt, who won the Nobel Prize in 2011 for their discovery. It is the most important discovery in the history of science. Discovering the dark energy and that it's causing the universe to expand at a faster rate was shocking. But there was something more baffling, and it was the strength of dark energy. Scientists could not explain why such a particular amount of dark energy exists in our universe. This mystery can be easily solved if we are part of a multiverse. The idea that space contains any energy is strange, but quantum mechanics shows us that there's a lot of activity at the microscopic level, and the math suggests that the amount of energy generated is enormous. But when the astronomers measured the amount of dark energy present in our universe, it was 0.138 times 10 to the power of 120, which seems an infinitesimal amount. This amount of dark energy is tiny, but if the dark energy would have been slightly stronger, it would rip apart all the matter and we wouldn't exist. So why is the amount of dark energy so less and so perfect for our existence? It's a mystery for us. But with the theory of multiverse, we have a solution. The amount of dark energy differs in every universe. In some, it might be so less that the matter would collapse in on itself, and hence nothing could exist. In some, dark energy is large that matter could never get a chance to form, and hence nothing would exist there. The amount of dark energy in our universe happens to be the right amount for our existence, and differs in every universe. But there's still a major piece of the puzzle missing: how we know that there's enough diversification within the multiverse so that every value for dark energy, including the curious value found in our universe, can be found somewhere. The answer comes from a newly born area of physics, the string theory. We all know that inside atoms are present the electrons and the nucleus. Inside the nucleus are protons, and inside these are smaller particles called quarks that make them. Physicists realize that these subatomic particles called quarks are also made of some smaller, tiny vibrating loops of energy, or strings. It's called the string theory. String theory states that everything that exists is made of these strings at the fundamental level. Just like a string of a violin produces a different kind of note depending on how they vibrate, strings can also create different particles based on how they vibrate. This theory paved the way for one master equation that underlies all the fundamental laws of physics. One master equation. But for the string theory to work, the math of the theory required something that opposes common sense, a property that opens the door for the multiverse: extra dimensions of space. We are all familiar with the three dimensions: length, width, and height, the fourth one being time. But let's leave it aside for now. But the mathematics of string theory proposes more than that. Its mathematics works only when strings vibrate, not only in these three dimensions, but in many more dimensions. So where are these extra dimensions of space, and why aren't they visible to us? Let's think of a wire and look at it from a distance. It looks like a line, one-dimensional. But what about an ant that's on the wire? It would see an extra dimension. And if we could shrink down billions of times then those ants, we will find extra dimensions curled up into loops everywhere in the space. The shape of those dimensions determine how these strings will vibrate, and these vibrations of space define different original properties of particles. So basically, these shapes of extra dimensions determines the underlying basic features of the universe. They are like the DNA of our universe and determine how our universe would behave. The major difficulty was that when the string theorists tried to find the shape of these dimensions, they had a bizarre result. In the beginning, there were 5 constant shapes, but eventually more shapes started coming, and there were millions of different possible shapes, each appearing equally valid as the other. The discovery was shocking. There were millions of string theories now. String theorists felt destroyed. What good is the theory that has millions of solutions? Finding anything is impossible in there. But some string theorists thought to look at the problem differently, a way that would lead to multiverse. They thought, this is great. There's no reason to be depressed. Enormous diversification of the constant shapes says string theory fits perfectly for cosmology and multiverse. Eventually, string theorists became convinced that the multiple solutions of the string theory represents a real and different universe. Each solution represented a different possible universe. String theory was describing a multiverse, a very distinct multiverse. Now, there were 3 ideas that were all indicating towards a single theory, a same conclusion, a multiverse. These were the eternal inflation, which we discussed in the first part, dark energy, and the string theory. These theories together revived the idea that Wilken and Lind worked on 10 years before and were supporting the idea of a multiverse. Different lines of research were focusing on one idea, and the theory of multiverse seemed convincing. All the various alternative universes out there have a different amount of dark energy naturally, and the unique shapes of these extra dimensions. Today, many debate the idea of the multiverse. We can only wonder how these universes might look. Some might differ vastly from ours, having features we cannot even imagine, and some might be very similar to us. Scientists like Alan Guth, Alex Villikin, Brian Greene, and others continue to find more clues for the multiverse, while many are against the idea. The debate will go on in the coming future. Who knows, we might be able to prove its existence even more perfectly.